What we have to do in example 4 is evaluate this function x squared plus 7 for x plus delta x, and then we have to evaluate this strange looking fraction that is called the difference quotient. So it might seem a little strange that we would be evaluating like this, but this is going to provide the formula for what's called the derivative that we're going to learn about very soon. What this is it's saying I want to evaluate this function at something that's just a little bit bigger than x. That delta x represents a small, infinitesimally small change in x. So to evaluate our function at this x plus delta x, what we do is we take our function, but instead of x, we're going to put x plus delta x and square that because x was squared, and now we're evaluating at x plus delta x. And so we now have this expression x plus delta x squared plus 7. This term will show up a few times over the next few sections, so it might be helpful just to remember what this one does. This is the square double square shortcut, where you square the first term, x squared, then you multiply the two terms together. X times positive delta x is x delta x, and you double that, so that's positive 2x delta x, and then the last term is delta x squared. Notice that I put the delta x in parentheses so that I am implying that I'm squaring that whole thing. Don't forget the plus 7. That's a very common mistake, is to forget anything else in your expression. And so that there will represent f evaluated at x plus delta x. Now for part B, we're going to start with that term that we just found, f of x plus delta x. Whenever you're evaluating one of these difference quotients, it's always a good idea for me to evaluate the f of x plus delta x before I plug it into this big fraction. There's just a lot going on in this function, and so I wouldn't want you to get everything all mixed up. So I'm going to take the f of x plus delta x that we've already evaluated, and then I need to subtract my original function. Notice here that I do put it in parentheses so that I remember that I'm going to have to subtract that entire expression, and then the denominator is delta x. The next thing we need to do is start to simplify. Everything for the first part is already simplified, but I need to subtract both the x squared and the positive 7. And then the next step is we are going to simplify. Every term that does not have a delta x should simplify. It should cancel. X squared minus x squared, that is 0. Positive 7 minus 7 is 0. So I can cross those out. I'm left with 2x delta x plus delta x squared over delta x. The last step is always going to be factoring out a delta x. So in the numerator, if I take a delta x from the first term, I'm left with 2x, and then with the second term, I can factor out a delta x, leaving me with a single delta x over delta x. What that now does is I can cancel the delta x, and my final answer is 2x plus delta x.